Solution containing 30 gram of non-volatile solute exactly in 90 gram of water has a vapor pressure of 2.8 kilopascal. Further, 18 gram of water is then added to the solution. The new vapor pressure becomes 2.9 kilopascal. Calculate the molar mass of the solute and vapor pressure of water at 298 Kelvin. So vapor pressure of water means P10 we have to calculate, and molar mass of solute we have to calculate M2. Here either we can directly use Rolle's law or we can use relative lowering of vapor pressure. So first case, the mass of solute is given as 30 gram. So W2 is equal to 30 gram. Mass of solvent, it is 90 gram of water, so W1 is equal to 90 gram. And after adding the non-volatile solute, the vapor pressure of the solution becomes 2.8 kilopascal. Similarly, in case 2, mass of solute is same, W2 is equal to 30 gram, and mass of solvent is equal to, we have added extra 18 gram of water, so 90 plus 18, 108 gram, and P1 is equal to 2.9 kilopascal. Now, W1 is given, so we can write molar mass of solvent is equal to, solvent is water, so 18 gram. Here we have to calculate molar mass of solute. Now, according to Rolle's law, we know P1 is equal to P10 chi1. Now, first let us calculate chi1. Chi1 is equal to N1 by N2 plus N1. That is equal to, N1 means number of moles of solvent. So mass of solvent is 90 and by molar mass is 18. Here N2 is equal to W2, mass of solute is 30 gram, and molar mass we have to calculate plus 90 by 18. So when we simplify, we will get mole fraction is equal to 5 by 30 by M2 plus 5. Now let us substitute this in the Rolle's law equation. P1 is equal to P10 chi1. So P1 is given in the question 2.8 kilopascal. So let us write 2.8 kilopascal for P1. That is equal to P10 we don't know into chi1. 5 by 30 by M2 plus 5. So let us take 5 as common factor. P10 into 5 from the numerator as well as from the denominator. So 1 by 6 by M2 plus 1. Now let us take else 5 and 5 cancels. That is equal to P10 into 1 by 6 plus M2 by M2. That is equal to P10 into M2 by 6 plus M2. So 2.8 is equal to P10 into M2 by M2 plus 6 or 6 plus M2. That let it be equation 1. Similarly for case 2, there P1 is equal to 2.9 is equal to P10 into chi1. So here mass of solute is 30 and mass of solvent is 108. So number of moles of solvent 108 by 18 divided by 108 by 18 plus 30 by M2. So 108 by 18 when we simplify, we will get 6. Here also we will get 6. So we can take 6 common factor from numerator and denominator. So 6 by 6 into 1 by 1 plus 5 by M2. 6 we can cancel. That is equal to P10 into, when we take the LCM, 1 by M2 plus 5 by M2. that is equal to P10 into M2 by M2 plus 5. So 2.9 is equal to P10 into M2 by M2 plus 5. Let it be equation 2. Now let us divide equation 2 by equation 1. That implies 2.9 by 2.8 is equal to P10 into M2 by M2 plus 5 divided by P10 into M2 by M2 plus 6. P10 cancelled. M2 and M2 also cancelled. So 2.9 by 2.8 is equal to 1 by M2 plus 5 divided by 1 by M2 plus 6. So M2 plus 6 will go to the numerator. M2 plus 6 by M2 plus 5. Now let us cross multiply. 2.8 M2 plus 6 into 2.8 is equal to 2.9 M2 plus 5 into 2.9. Now 6 into 2.8 will be 16.8. Then 5 into 2.9 will be 14.5. So 14.5, let us bring to the left hand side. 2.9 M2 minus 2.8 M2. So we will get 2.3 is equal to 0.1 M2. So M2 is equal to 2.3 by 0.1, that is equal to 23 gram per mole. Now we got the molar mass of solute. Now let us substitute this molar mass in one of the equation and we can find out the value of P10. So let us take the equation. P1 is equal to P10 chi1. So 2.8 is equal to P10 into M2 by M2 plus 6. That is equal to P10 into M2 is 23, 23 plus 6. So P10 into 23 by 29 is equal to 2.8. Therefore, P10 is equal to 2.8 into 29 by 23. That we will get 3.53 kilopascal. A 5% solution of cane sugar in water has a freezing point of 271 Kelvin. Calculate the freezing point of 5% glucose in water if freezing point of pure water is 273.15. So case 1 for cane sugar. Mass of solute is equal to 5 gram. Mass of solvent is equal to, here 5% means 5 gram solute in 100 gram of solution. So mass of solution is equal to 100 gram. So mass of solvent will be 100 minus 5, that is equal to 95 gram. Here the solvent is water and molar mass of solute is equal to M2. Formula C12H22O11, that is equal to 12 into 12 plus 22 into 1 plus 16 into 11. So when we simplify, we will get 342 gram per mole. Now let us calculate delta TF, that is equal to T0F minus TF. T0F is the freezing point of pure water, that is equal to 273.15, and when we added the 5 gram of solute cane sugar in water, we got the freezing point as 271. So the difference is 2.15 Kelvin, that's the depression in freezing point. Now delta TF is equal to Kf into molality, mass of solute by molar mass divided by mass of the solvent in kilogram. So we can write W1 into 1000 by W1. Now Kf is equal to, now we have to calculate Kf. So delta TF into M2 into W1 divided by W2 into 1000. Now let us substitute the values. Delta TF is equal to 2.15, molar mass is equal to 342, mass of solvent is 95 and mass of solute is 5 into 1000. Now we got Kf. So when we simplify this, we will get 13.97 Kelvin kilogram mole raised to minus 1. Now let us substitute this value for glucose. Second case, case 2. Their mass of solute is 5 gram, mass of solvent is 95 gram, 100 minus 5, 95 gram. Molar mass of solute is equal to, here the solute is glucose, so 6 into 12 plus 12 into 1 plus 16 into 6. When we simplify, we will get 180 gram per mole. Delta TF is equal to Kf into molality, mass of solute by molar mass into 1000 by W1. Now, delta TF is equal to Kf, we calculated 13.97 into mass of solute 5 gram, 5 into 1000 divided by 180 into 95. So when we simplify this, we will get 4.08 Kelvin. Now delta TF is equal to T0F minus TF is equal to 4.08. Therefore, TF is equal to, it is depression in freezing point, T0F minus 4.08, 273.15 minus 4.08, that is equal to 269.07 Kelvin. Two elements A and B form compounds having formula AB2 and AB4. When dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it by 1.3 Kelvin. The molar depression constant for benzene is 5.1 Kelvin kilogram mole raised to minus 1. Calculate the atomic masses of A and B. So first case we can write for AB2. Mass of AB2 is equal to 1 gram. Mass of solvent, mass of benzene is equal to 20 gram. Delta TF is equal to 2.3 Kelvin. Kf is equal to 5.1 Kelvin kilogram mole raised to minus 1. Delta TF is equal to Kf into molality, mass of solute, mass of AB2 by molar mass of AB2 divided by mass of solvent, mass of benzene by 1000. That means it will go to the numerator. That is equal to 2.3 is equal to Kf. So we can rearrange. Molar mass of AB2 is equal to Kf is given as 5.1, mass of solute 1 into 1000 divided by delta TF is 2.3 into mass of solvent is 20. So when we simplify this, we will get 110.87 gram per mole. Similarly, we can do for MAB4 also. Molar mass of AB4 is equal to, only we have to change the depression in freezing point. Kf is same for benzene, mass of solute is same into 1000 divided by 1.3 into 20. When we simplify this, we will get 196.15. Now, we got molar mass of AB2 and AB4. Molar mass is the sum of the atomic mass. So, we can write MAB2 is equal to A plus 2B. A plus 2B. MAB2. Molar mass of AB2 means sum of the atomic mass. So that is equal to 110.87. Similarly, we can write MAB4 is equal to A plus 4B. That is equal to 196.15. Equation 1 and equation 2. Now we can do equation 2 minus equation 1. So A and A we can subtract 0. 4B minus 2B we will get 2B is equal to 196.15 minus 110.87. So we will get 85.28. So B is equal to 85.28 by 2. So we will get 42.64 U. Atomic mass of B we got. Now let us substitute in any one equation and find out the atomic mass of A. A plus 2B means 85.28 is equal to 110.87. Let us substitute in the first equation. So A is equal to 110.87 minus 85.28. When we simplify this, we will get 25.59. 25.59 U. So these are the atomic masses of A and B. 300 Kelvin 36 gram of glucose present in a liter of its solution has an osmotic pressure of 4.98 bar. If the osmotic pressure of the solution is 1.52 bar at the same temperature, what would be its concentration? So we have two cases. First case, mass of solute is given as 36 gram. Molar mass of solute, glucose is the solute, its molar mass is 180 gram per mole. Osmotic pressure is equal to 4.98 bar. If the osmotic pressure of the solution is 1.52 bar at the same temperature, what would be its concentration? So pi is equal to CRT. C refers molarity. Molarity is equal to number of moles divided by volume of solution in liters. Here in question it is mentioned 36 gram of glucose present in a liter. So volume is 1 liter. So 4.98 is equal to mass of solute is equal to 36 by molar mass is 180 divided by 1. Then we will get molarity. R is the universal gas constant and T is the temperature. So this is the equation for the first case. Then case 2, osmotic pressure is given as 1.52 bar. Concentration we don't know. Universal gas constant is same and temperature also mentioned as same temperature. So this is equation 2. Now equation 1 by equation 2. 4.98 divided by 1.52 is equal to 36 by 180, that is equal to 1 by 5, that is equal to 0.2. 0.2 RT divided by CRT. Now RT and RT we can cancel. Therefore C is equal to 1.52 into 0.2 divided by 4.98. That is equal to, when we simplify, we will get 0.061. That much mole per liter. Next, the most important type of intermolecular attractive interaction in the following pairs: normal hexane and normal hectane. Normal hexane and normal hectane both are non-polar molecules. So the force of attraction between two different type of non-polar molecule, it is London force. London force or dispersion force. Iodine is non-polar and carbon tetrachloride also non-polar. So the force of interaction is London force or dispersion force. Sodium chlorate is an ionic solid, Na plus and ClO4 minus. So this is ionic solid and water is a polar solvent. So the interaction between these two is ion dipole interaction. Methanol and acetone. Methanol is a polar molecule and acetone also polar molecule. So the interaction between this is dipole-dipole interaction. Acetonitrile is polar and acetone is also polar. So the interaction between these two is dipole-dipole interaction. Fluid solvent interaction, arrange the following in the increasing order of solubility in normal octane and explain. Cyclohexane KCl CH3OH CH3Cl. Here we have to check the solubility in octane. So octane is a non-polar solvent. Octane is non-polar. So as per the rule, non-polar solvents are soluble in non-polar solvents. Non-polar substances soluble in non-polar solvents. So KCl cyclohexane is non-polar. KCl solid is ionic. CH3OH is polar and CH3CN also polar. So according to this, ionic solids are least soluble in non-polar solvents. So KCl has least solubility. Then out of polar, CH3OH is more polar than CH3CN. So CH3OH is less soluble than CH3CN. Then cyclohexane is a non-polar solvent. So that is soluble in octane, because octane is also non-polar. Cyclohexane. If the density of some lake water is 1.25 gram per milliliter and contains 92 gram of sodium ions per kilogram of water, calculate the molality of Na plus ions in the lake. So molality is equal to number of moles of the solute divided by mass of solvent in kg. Here number of moles we can expand mass by molar mass. So given mass is 92 and molar mass of sodium is 23 gram per mole. Then divided by mass of the solvent in kilogram. Here per kilogram of water, so it's 1. So when we simplify, we will get 4 moles. 4 mole kilogram raised to minus 1, because here this is 1 kilogram. If the solubility product of copper sulfide is 6 into 10 raised to minus 16, calculate the maximum molarity of copper sulfide in aqueous solution. Maximum molarity means we have to find out the solubility. Maximum molarity, that is equal to solubility. So solubility product is the product of concentration of ions in saturated solution. So copper sulfide we can ionize into Cu2 plus S2 minus. So solubility product is equal to product of concentration of ions, that is product of Cu2 plus and S2 minus. Let S be the solubility of Cu2 plus, then we can write the solubility of S2 minus also S itself, because they are in the ratio 1:1. So S square. Solubility product is given in the question as 6 into 10 raised to minus 16 is equal to S square. So S is equal to, solubility is equal to square root of 6 into 10 raised to minus 16. Square root of 6 is equal to 2.45 and square root of 10 raised to minus 16 is equal to minus 8. So that much mole per liter. So maximum molarity means that is the solubility. Calculate the mass percentage of aspirin in acetonitrile when 6.5 gram of aspirin is dissolved in 450 gram of acetonitrile. So mass percentage of aspirin means mass of aspirin, mass percentage of aspirin equal to mass of aspirin divided by total mass of solution, that is mass of aspirin plus mass of acetonitrile into 100. Mass of aspirin is given as 6.5 gram. Mass of solution is sum of masses of aspirin and acetonitrile, that into 100. So that will be equal to 6.5 by 456.5 into 100. When we simplify this, we will get 1.424 percentage. Similar to morphine is used to combat withdrawal symptoms in narcotic users. Dose of nalorphine is 1.5 milligram. Calculate the mass of 1.5 into 10 raised to minus 3 molar aqueous solution required for the above dose. So here 1.5 into 10 raised to minus 3 molar That means 1.5 into 10 raised to minus 3 mole of nalorphine in 1000 gram solvent, that's water. So molar mass of nalorphine is equal to 19 into 12 plus 21 plus 14 plus 16 into 3. So when we simplify, we will get 311 gram per mole. Now, mass is equal to number of moles into molar mass. That is equal to 1.5 into 10 raised to minus 3 into 311. So when we simplify, we will get 0.467 gram. So we know 1000 gram of solution contains 0.467 gram of nalorphine. So total mass of solution is equal to 1000 plus, that's mass of solvent, then mass of solute is 0.467, so 1000.467. So 0.467 gram nalorphine requires 1000.467 gram solution. So 0.467 gram of nalorphine, the solution required. Solution required is this. So 1 gram nalorphine, solution required is 1000.467 by 0.467. We have 1.5 milligram, that is equal to 1.5 into 10 raised to minus 3 gram nalorphine. Solution required is, so we are calculating the solution required for the above dose. 1000 by 1000.467 by 0.467 into 1.5 into 10 raised to minus 3, that is equal to 3.21 gram. Amount of benzoic acid required for preparing 250 ml of 0.15 molar solution in methanol. Here molarity is given. Molarity is equal to 0.15. Volume of solution is equal to 250 ml. Molar mass of solute is equal to C6H5COOH. So we have total 7 carbon, 12 into 7 plus 6 hydrogen 6 and 2 oxygen 32. So total is 122 gram per mole. Now let us substitute the value in the molarity equation. Molarity is equal to mass by molar mass. So mass of solute we have to calculate. Molar mass 122 divided by volume is 250. 250 by 1000. So that is equal to, molarity is given. So we can substitute that also, 0.15. So 250 by 1000, that is equal to 1 by 4. W2 by 122 into 4 is equal to 0.15. Therefore W2 is equal to 122 into 0.15 divided by 4. that is equal to 4.575 gram. The depression in freezing point of water observed for the same amount of acetic acid, trichloroacetic acid and trifluoroacetic acid increases in the order given above. Explain briefly. The depression in the freezing point of water when 10 gram of 2-chlorobutanoic acid is added to 250 gram of water. Ka is 1.4 into 10 raised to minus 3. Kf is equal to 1.86. Here mass of solute is given as 10 gram. W2 is equal to 10 gram. W1 is mass of solvent, that is equal to 250 gram. Then let us calculate molar mass of solute. 2-chlorobutanoic acid, here we have 4 carbon atom. So 12 into 4 plus 7 hydrogen atom plus 1 chlorine atom and 2 oxygen atoms. So 2 into 16, 32. So when we simplify, we will get 122.5 gram per mole. Then we have to calculate the depression in freezing point, that is delta TF is equal to I into KF into molality. So first let us calculate molality. Molality is equal to number of moles, that is mass by molar mass. 10 by 122.5 divided by mass of the solvent in kilogram, that is 250 by 1000. So that will be 1 by 4. So we will get 40 divided by 122.5. 122.5 40 by 122.5, that is equal to 0.3264 mole kilogram raised to minus 1. Now, so molality we calculated, Kf is given in the question. Now we have to calculate I. So for calculating I, dissociation constant is given. So from that first we can find out alpha. Alpha is equal to root of Ka by C. So the dissociation constant is given in the question as 1.4 into 10 raised to minus 3. So 1.4 into 10 raised to minus 3 divided by, instead of concentration we can take molality as 0.3264. Then we will get the degree of dissociation. When we simplify, we will get the degree of dissociation as 0.065. Now we have to calculate the Van Hoff factor I. So alpha is equal to I minus 1 by n minus 1. So in the case of dissociation of acid, the acid is splitting into CH3, CH2, CHCl, COOH. This breaks down into CH3, CH2, CHCl, COO minus plus H plus. So here the number of moles in the product side is 2. That is equal to I minus 1 by 2 minus 1. 0.065 is equal to, so that is I minus 1 is equal to 0.065. So I equal to 1.065. So that's a Van Hoff factor. Now delta TF is equal to I into KF into M. So I is 1.065 and Kf is equal to 1.86 and molality is equal to 0.3264. So when we simplify, we will get delta TF as 0.65 Kelvin.